Hello everyone, welcome to my lecture video. First of all, let us see one of the most important topic called Laplace transform of periodic function. So this is one of the most important topic. So in the announced examination, they will ask one question compulsory. So before entering into the topic, now let us see what is periodic function. A function f of t is satisfies the periodic if it is satisfies the function f of t plus capital T equal to f of t. A function, if it is satisfies in this condition, then we say that the function is periodic. Let us see the example. F of t equal to sin t is one of the most suitable example for periodic function. Now let us verify this condition. So f of t plus capital T equal to f of t. So I am going to take f of t equal to sin t. So in order to verify LHS equal to RHS, in place of Ty, I am going to replace T plus capital T. Look at this, f of T plus capital T equal to sin of T plus capital T. So when it will be equal, now let us consider T by 2 pi, f of T plus 2 pi equal to sin of T plus 2 pi. So sin of 360 plus theta equal to sin theta. So therefore this becomes sin t. So equation from 1 and 2, LHS equal to RHS. Therefore sin t is a periodic function with the period 2 pi. So this is the basic definition of periodic function. Now our ultimate aim is to find what is the Laplace transform of periodic function. What is the Laplace transform of periodic function? Now let us see one of the most important question. Look at the question. Find the Laplace transform of the function f of t equal to t, 0 less than or equal to t less than or equal to a, and second one is 2a minus t, a is less than or equal to t less than or equal to 2a. So look at the function. The function can be splitted into two interval. The first interval becomes 0 to a, the function is t, and second interval a to 2a, the function is 2a minus t. Look at the period, with the period is 2a. Look at the ending interval, the ending point, the starting point is 0 and the ending point is 2a. The 2a is the period of this whole function. Now let us find the Laplace transform of this function. Look at the solution. So Laplace transform of periodic function. So the formula is, one of the most important formula is, when we are going to find Laplace transform of periodic function, we are going to apply this formula. The formula is Laplace transform of f of t. Laplace transform of f of t equal to 1 divided by 1 minus e power minus st. Look at the formula. L of f of t equal to 1 divided by 1 minus e power minus st integral 0 to t e power minus st f of t dt. So this is the formula. One more time I am going to tell you the formula. Look at the formula. You clearly try to understand the formula. So L of f of t equal to 1 divided by 1 minus e power minus st. This capital T is called as period of the function. Integral 0 to t e power minus st f of t into dt. In this problem, look at this. What is the period? The period is 2a. So therefore, in order to consider capital T by 2a. So in place of capital T by, we are going to replace 2a. So we are going to start the problem. Look at the first step. The first step is formula. That formula is very important. In that formula, in that capital T by, we are going to replace 2a. So therefore, L of f of t equal to, instead of capital T by, I am going to replace 2a. So 1 divided by 1 minus, instead of t by, I am going to replace 2a. So therefore this can be written as 1 minus e power minus 2as integral 0 to 2a, 0 to 2a e power minus st f of t dt. So this is the second step. So coming into the third one, L of f of t equal to, you have to write it as it is, 1 divided by 1 minus e power minus 2as integral 0 to a. Now why I am going to write 0 to a? Look at the function. The function can be split into two interval. The first interval is what? 0 to a. So therefore this 0 to 2a can be split into 0 to a and as well as a to 2a. The starting point is 0, ending point is 2a. The starting point is 0, ending point is 2a. So therefore, I am going to split it. So according to the given problem, integral 0 to a. So look at the function here. I am directly applying here the function. What is the given function in the interval 0 to a? In the interval 0 to a, the function is, what is the function? F of t equal to, f of t is equal to t. So instead of f of t by, I am replacing here t, and then you have to keep it as it is, e power minus st as it is. So no need to disturb that. So you have to write it integral 0 to a t into e power minus st into dt, plus coming into the second interval, the interval is what? 0 to 2a. So we can write it as integral a to 2a, a to 2a. The function is what? 2a minus t. So therefore 2a minus t into e power minus st into dt. See, look at the function. This function can be splitted into two intervals, 0 to a and as well as a to 2a. So we have to substitute that function. So this is the third step. So now we are going to integrate integral number 1 and integral number 2. So how we are going to integrate for this? The first one is by applying Bernoulli's formula. Second one is also applying Bernoulli's formula. Now let us consider, so this is for applying Bernoulli's formula. Already you know that Bernoulli's formula. What is Bernoulli's formula? Integral uv dx equal to uv1 minus u dash v2 plus etc etc, it is going on. So by applying this formula, we are going to evaluate this integral. Now, so according to this, I am going to consider this as a u equal to what? T, and v equal to what? E power minus st. Now I am going to differentiate with respect to this function. If you are differentiating with respect to t, what will happen here? So t, u equal to t, already you know that the formula, the differentiation of x is 1. Here the function is t, therefore u dash is represented as differentiation. So u dash equal to 1. So coming into the next one, v will be considered as what? E power minus st. Now you have to integrate with respect to t. So integration will be mentioned as v1. So v1 equal to e power minus st divided by minus s, because of integrate with respect to t. It is a function of t. So therefore the answer is what? E power minus st divided by minus s. You have to leave it this one. And look at the formula u v1 minus of u dash v2. So u dash v2. So u dash means what? We need to integrate one more time. So if you are going to integrate one more time for this function, so this can be written as v1 can be written as v2 equal to, because you are going to differentiate one more time, v2 equal to e power minus st, again or minus s is coming. So therefore we what? The answer can be written as s square. So e power minus st divided by s square. So this is the procedure to find integration and as well as the differentiation. So coming into the next one, so simultaneously I am doing both the integral. So this is the procedure for first integral. Coming into the second one, the only difference is u. So v is common for both the integral, v is common. So I am going to take u is equal to what? 2a minus t in this integral. I am talking about second integral 2a minus t. Now you have to differentiate with respect to t, u dash equal to, this will be a constant term, therefore 0. So this is minus t can be written as what? Differentiate with respect to t. So this is minus 1. Now applying the Bernoulli's formula, look at the formula. So here, so you have to continue this step. So equal to 1 divided by L of f of t equal to 1 divided by 1 minus e power minus 2as. You have to write it as it is. So look at this. So this is a look like u v dx. So instead of that, what is the answer? U v1 minus of u dash v2. So I am going to apply this formula u v1 minus u dash v2. What is the limit for first integral? 0 to a. So this is 0 to a plus second integral. Second integral also same integration formula, same Bernoulli's formula. Now I am applying here the formula u v1 minus of u dash v2. The limit is a to 2a. Now we are going to substitute all the values here and apply the limit and simplify. Finally, we will get the answer. So one of the most important problem and also one of the easiest problem. So definitely we will get 8 mark surely in the university examination. Right? Look at that. So in place of u by, what I am going to replace? T, u v1. Look at this. So this is u, t, v1, e power minus st divided by minus s. I am taking in front of that minus, because so if you are multiplying these two terms will get minus of t into e power minus st divided by s u v1 minus of this minus you have to keep it as it is minus u dash v2. What is u dash? U dash equal to 1 v2. Look at this v2. What is this? Minus 1 into e power minus st divided by s square. So this is the first integral. The next one, coming into the next one, plus this plus you have to keep it as it is. The next one u v1, same thing, this will be considered as u v1. This minus you have to keep it in front. So minus of 2a minus t into e power minus st divided by s. So this is the first term u v1 minus of u dash v2 minus already one minus is there, so here minus, so minus minus plus you have to write it minus minus into plus 1 into, so what is answer? E power minus st divided by s square. So this is e power minus st divided by s square. The limit is what? Second one, a to 2a. Now we are going to apply upper limit and as well as lower limit. Upper limit and as well as lower limit. Here how many terms are there? Two terms are there. When you are applying upper limit, we will get two terms. When you are applying lower limit, we will get two terms. And second one, when you are applying two terms, when you are applying upper limit, we will get two terms minus of lower limit. Then after that, you have to simplify. Finally, we will get the solution. Now, we are going to apply the limit instead of t, because of it is a function of t. So, therefore, instead of t, I am going to substitute a, upper limit. So, this is minus a. You have to keep it as it is. 1 divided by 1 minus e power minus 2a. No need to disturb for this. You have to keep it as it is. Then, instead of t by, I am going to replace a. So, minus of a into e power, instead of t, I am replacing a. So, therefore, this can be written as e power minus as divided by s minus 1 into e power minus as divided by s square. So, this is upper limit minus of lower limit. Instead of t by we are applying 0, the whole term becomes 0. Therefore, you have to write it 0. And next one is here, if you are applying 0 instead of t by e power 0, 1. So, therefore, 1 by s square. So, right, you try to understand that, very simple. You have to apply upper limit and as well as lower limit. Finally, we will get this result. Plus, coming into the next one, look at that. I am going to apply 2a upper limit instead of t. So, 2a minus 2a. So, this becomes 0. The whole term becomes 0. This can be written as 0. And here I am applying instead of t by 2a. What is the answer? E power minus 2as divided by s square. So, this is second term and minus of lower limit. So, upper limit for two terms minus of lower limit. You have to keep it as it is, this minus the lower limit instead of t by a. I am going to replace instead of t by a. Then what is the answer? This minus you have to keep it as it is. So, minus of 2a minus a. What is the answer? 2a minus a. This minus you have to keep it as it is. Then instead of t by a. So, this become e power minus as divided by s. And as well as second term. So, plus for this one plus e power minus as divided by s square. So, these are all the terms we will get when you are applying upper limit, lower limit for both the integral. And finally, we are going to simplify. We are going to multiply all the minus and simplify. Finally, we will get the answer. Right. Look at this. You have to keep it as it is, this term. So, this as minus of a into e power minus as divided by s. Then you have to keep it first and second term as it is. No need to disturb that. And if you are multiplying inside the minus, we will get what? Minus minus plus. So, 1 by s square. So, you have to write it as it is, 1 by s square plus. And second integral, coming into the second integral, e power minus 2as divided by s square. You have to write it e power minus 2as divided by s square. So, if you are multiplying this minus minus plus, so this is plus into a into e power minus 2as divided by s. So, when you are multiplying inside the minus, this will be minus e power minus as divided by s square. Look at all the terms. The first term and this one will be cancelled because of this is minus term and plus term. So, you have to cancel all those things. So, finally, we will get what? So, you have to write this as a first term 1 divided by s square. You have to keep it as it is. Look at here. So, I am going to do one modification for here. So, 1 divided by 1 minus e power minus 2as can be written as 1 can be written as what? 1 square minus of e power minus 2as. This 2 can be written as in the power of in the exponential function e power minus 2a is the whole square because of e power n whole power m can be written as e power mn like that. So, by applying that rule, so 1 square minus e power minus 2as can be 2as can be written as e power minus as the whole square. So, this is the answer for this one. and this is the small modification. Coming into the next one, so you have to write it 1 divided by a square as it is, 1 divided by a square plus e power minus a. This will be the second term. E power minus 2a divided by a square is a second term. And if you are adding these two terms, so look at that. So in this term and this term both are same term. So I am going to add these two terms. So minus and as well as minus. So minus of 2 times of e power minus a is divided by a square. So look at that. So this is a three terms. When you are simplifying all the integral, we will get finally this 3 terms, right? Yes. And coming into the next one, 1 divided by e power minus a is the whole square. So this is look like a square minus b square. Look at this. So this is what? A square minus b square. What is the formula? A square minus b square can be written as what? A plus b into a minus b. So I am going to apply this formula. So this is a. A means what? 1 plus e power minus as, a plus b. So this is a plus b and a minus b. So 1 minus e power minus. So this is can be splitted as what? 1 square minus a square can be splitted as 1 plus e power minus as and into 1 minus e power minus as. Right. Coming to the next term. So this can be written as 1 can be written as 1 square. And same rule we can apply here. E power minus 2as can be written as e power minus as the whole square minus of 2 times of 1 into e power minus as whole divided by the common, all the 3 terms are a square. So therefore you have to take it common, a square. Look at the term. So this is look like a square plus b square minus 2ab. So a square b square. So this is of the form. What is the form? What is of the form? A square plus b square minus 2ab. So what is the formula? A minus b the whole square. I am going to write here. What is a? 1 minus e power minus a is the whole square. So if you are expanding this, we will get this, right? And look at this term, 1 divided by 1 plus e power minus 1 divided by 1 minus e power minus as. So this is 1 minus e power minus as, 1 minus e power. So we'll get cancel. Here this is power 1 and power 2 get cancelled. Finally remaining 1 power is there. So in the numerator can be written as 1 minus e power minus as divided by what? 1 plus e power minus as. This a square can be right in this side, in this corner. So finally we'll get, look at the result. So L of f of t equal to this a square can be written as in this side. So 1 divided by a square into in the numerator value. What is the numerator value? 1 minus e power minus as divided by 1 plus e power minus as. So now look at this. We have one formula for this. The numerator and denominator both the terms are same. The symbol is different, minus and plus. So we can write it as, if it is e power minus as means we can write it as tan h as by 2. If it is as by 2 means we can write it as as by 4. We can write it as in this power by half, right? So therefore finally we'll get 1 divided by a square into the formula for this is tan h as by 2. So this is the final answer for what? The periodic function of this term. So f of t equal to t 0 less than or equal to t less than or equal to a, and 2a minus t, a is less than or equal to t less than or equal to 2a. So one of the most important problem in the analytic examination. In same way we are going to solve one more problem, another problem. Look at the problem, problem number 2. Same question. The function is different. Find the Laplace transform of f of t equal to, the function is different, f of t equal to, look at that. So this can be written as capital E minus capital E, same thing. So some of the university questions they will change 0 less than or equal to t less than or equal to b, b less than or equal to t less than or equal to 2b. The only a is replaced by b. So remaining all the terms are same, right? Look at this. With the period is 2a, same thing. How we are going to solve for this problem? Look at this, right? Same procedure. We can apply same procedure. What is the formula? Same formula. So find the Laplace transform of f of t equal to e 0 less than or equal to t less than or equal to a minus e, a is less than or equal to t less than or equal to 2a with the period is 2a, right? Now we are going to apply the concept of what? The formula for Laplace transform of periodic function. Already you know that. What is the formula? L of f of t equal to 1 divided by 1 minus e power minus st integral 0 to t e power minus st f of t dt with the period is what 2a by applying same procedure. Instead of t by you have to replace 2a. So 0 to 2a e power minus st f of t into dt, right? So 1 divided by 1 minus e power minus 2a is same thing you can apply here. We can split it into two interval 0 to a and a to 2a. The only difference is what is the function for first one, what is the function for first one, what is the function for second one. The first one is e, capital E. So this can be written as instead of that is capital E. So instead of that I am going to replace capital E. So right, so this is the only difference between previous one and this one, right? So this will be the constant term, this will be the constant term. So no need to apply for what Bernoulli's formula. When the integral having two function, we can apply Bernoulli's formula. Otherwise no need to apply for Bernoulli's formula, directly we can integrate as it is. So here what I am going to do is I am going to take it outside the constant term. So e and as well as minus e is the constant term, therefore I am going to take it outside the constant term. What is the constant term here? So this is 1 divided by 1 minus e power minus 2as. If I am going to take it as constant term here, take it outside, then this can be written as integral 0 to a e power minus st into dt minus, this can be, if you are taking outside only for e, this minus you have to keep it as it is here. So this is a to 2a e power minus st into dt, right? Look at this. Now we can apply the integration. See here, look at this. So one of the most important problem for this very simple idea, very simple concept, right? Now I am going to apply L of f of t equal to e divided by, look at this, e divided by 1 minus e power minus 2as, 1 minus 2as. So I am going to apply integration for this. What is the integration? E power minus st divided by minus s. The limit is what? 0 to a plus. Second one is not for plus, here minus. So this is minus. What is second one? Same integration, e power minus st divided by minus s. The only difference is limit a to 2a. Okay. Now we are going to apply upper limit and as well as lower limit. Upper limit and as well as lower limit. So I am going to connect in this problem to previous problem. How I am going to connect? Look at this beauty of this problem, right? So here e divided by, same thing as it is. This can be written as what? 1 minus e power minus 2as. 1 minus e power minus 2as. I am going to apply upper limit. What is upper limit? E power minus as divided by minus s, upper limit. Instead of a, instead of t by, I am going to apply a. Minus of lower limit, minus minus plus. So 1 divided by s. So this is upper limit. Minus of lower limit. Instead of that, I am going to apply e power minus 2as divided by minus s, upper limit, minus lower limit, upper limit. So instead of t by, I am replacing 2a. So we will get e power minus 2as divided by s. Minus of lower limit, minus minus plus. So e power minus st divided by s, right? Now you have to simplify this. So already you know that how to write for this. So this is 1 square minus e power minus as the whole square. You have to write it as it is. Then you have to keep it as it is. So this is e power minus as divided by minus s plus 1 divided by s. If you are multiplying inside the minus, then what is the answer? So e power minus 2as divided by minus minus plus. If you are multiplying this, minus e power minus here. So instead of t by a, so e power minus as. So therefore e power minus as divided by s, right? Now look at this. I am going to connect for this. Here this 1 by s, you have to write it here 1 by s as it is, 1 by s. The next one, you have to add these two terms because of both the terms are same. So you have to add these two terms. So finally, what we'll get here, if you are adding these two terms, 2 times of e power minus a s divided by not for a square, yes, right. So when you are adding these two terms, we'll get this minus, and this one you have to keep it as it is, this term e power minus 2as divided by s. So look at this. So this is the beauty of this previous problem and then this problem. So when you are integrating this, it will be connected like this. So you have to keep it in your mind. So this can be in the form of a minus b the whole square. You have to connect a previous problem and this in this problem. So only difference is denominator is a square in the previous problem. In this problem is only for s. Okay, right. Now you have to split as it is. In the numerator becomes only for what? E. You have to write it in the numerator as only for e. The denominator, what is denominator? Denominator becomes only for s, not for s square, only for s. Okay, here s. So e divided by s. So the final answer is, what is the answer? E divided by s into tan h as by 2 is the answer. The only difference is previous problem and this problem is, in this previous problem the answer is 1 divided by s square into tan h as by 2. In this problem, capital E divided by s into tan h as by 2. Am I right? Right. So here same concept we can apply here. This is look like what? 1 plus e power minus 2as minus of e power minus 2as. So this is what? 1 square plus e power minus as the whole square minus 2 times of 1 into e power minus as. This is look like a minus b the whole square. So you have to write it 1 minus e power minus as the whole square divided by s square, right? Then in this term it cancel, and numerator we have only for what? 1 minus e power minus as. In the denominator we have 1 plus e power minus as, right? By applying the formula. What is the formula? Already I told you that the formula is e by s into tan h as by 2. So definitely they are asking the university examination. So you try to understand the problem very clearly, right? So this is the most important topic in the university examination. So now coming into the next topic, preliminaries of Laplace transformation. Preliminaries of Laplace transformation. Right. So one of the basic formula. So this will apply in engineering concept. For example, in EC, electronics and communication engineering, the people are using in Laplace transformation for signals and system. So there are a lot of applications are there in Laplace transformation. Now I am going to tell you that the preliminary definition of Laplace transformation and the elementary functions of Laplace transformation. Right, look at that. So what is the definition of Laplace transform? L of f of t equal to, L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. So this is one of the most important definition. This is the main primary definition of Laplace transform is L of f of t equal to integral 0 to infinity e power minus st f of t dt. So based on this definition, we are going to find the Laplace transform of constant function, exponential function, algebraic function, trigonometric function and a hyperbolic function. Now I am going to give some preliminary main function, that means the main important functions of Laplace transformation, right? The first function is L of 1. What is the answer for this? L of 1. L of 1. I am going to prove a few examples for this. You have to keep it in your mind. L of 1 equal to 1 by s. And second one is L of e power at 1 divided by s minus a. If it is plus, you have to write it minus. And third one is L of e power minus at equal to 1 divided by s plus a. And fourth one is L of t power n equal to n factorial divided by s power n plus 1. So for example, I am going to write it. So L of t power 1, instead of n by, I am going to replace 1. So what is the answer? 1 divided by s square t. So sixth one, L of t square equal to, what is the answer? t square equal to 2 factorial 2 divided by s cube L of t square. This is sixth one. And seventh one is L of sin at equal to a divided by s square plus a square. And eighth one is L of cos at equal to s divided by s square plus a square. And ninth one is L of sin hat equal to a divided by s square minus a square. And the tenth one is L of cos hat equal to s divided by s square minus a square. Right? Look at the formula. It's one of the basic and primary formula when you are learning the Laplace transformation. So what is the formula? The first one is L of 1 equal to 1 by s. L of e power at equal to 1 divided by s minus e. See, look at this. This is constant function. L of 1 equal to 1 by s. What is the answer for L of 2? 2 equal to 2 by s. What is the answer for L of 100? 100 by s. L of 200. What is the answer? 200 divided by s. Whatever be the constant, we can write it as constant divided by s. Right? So, this is the first one. And the second one is L of e power at equal to 1 divided by s minus a. Look at this. If it is plus a, we can write it as minus. L of e power minus at 1 divided by s plus a. L of t power n equal to, what is this? So, look at this. So, this is constant function, this is exponential function, and 4, 5, 6 is algebraic function, 7, 8 is trigonometric function, 9, 10 will be a hyperbolic function, right. So, fourth one is L of t power n equal to n factorial divided by s power n plus 1. And fifth one is instead of n by I am going to replace 1. So, L of t equal to 1 divided by s square. So, you have to keep it in your mind when you are studying in the Laplace transform. This is the most important primary formula. So, L of t square equal to 2 divided by s cube. And seventh one is L of sin at equal to a divided by s square plus a square. L of cos at equal to s divided by s square plus a square. Look at this. The difference is sin means we can write it as here a. Cos means we can write it as is here s. And same formula hyperbolic function, the only difference is minus. The remaining term will be sum. So, L of sin hat equal to a divided by s square minus a square. L of cos hat equal to s divided by s square plus a square. Right. So, this is the what? The primary formula for Laplace transformation. Coming into the next one, inverse Laplace transform. One of the most important one, right? So, this is Laplace transform, LT. So, this is here I am going to write it as ninth one is L of sin hat equal to a divided by s square minus a square. And 10th one I am going to write it here L of cos hat equal to s divided by s square minus a square. Okay, right here. So, this is Laplace transform. The next one is inverse Laplace transform. Inverse Laplace transform. What is inverse Laplace transform? Here, the Laplace transform is a function. It will be transforming into t to s. The function is transformed into what? T to s. But here, the function is transformed into s to t. Look at this. So, this is the only difference between Laplace transform and inverse Laplace transform. So, this L is goes to this side. So, answer is L inverse of 1 by s is equal to 1. The first formula I am going to write it in directly. Look at that, there is a relation between Laplace transform and inverse Laplace transform. And the second one is, so L inverse of 1 divided by s minus a. So, here is the question, here is the answer. Here the question will be the answer, right? So, what is answer? So, this is e power at. And third one is L inverse of 1 divided by s plus a equal to e power minus at. And fourth one is L inverse of n factorial divided by s power n plus 1 equal to, what is answer? T power n. And fifth one is L inverse of 1 by s square c equal to t. And sixth one is L inverse of 2 divided by s cube equal to t square. And seventh one is L inverse of a divided by s square plus a square equal to a divided by s square plus a square equal to sin a t. And eighth one is L inverse of s divided by s square plus a square equal to cos a t. This is cos a t. And ninth one is L inverse of a divided by s square minus a square equal to sin h a t. And tenth one is L inverse of s divided by s square minus a square equal to cos h a t. So this is the main difference between Laplace transformation and the inverse Laplace transform. Look at here, the Laplace transform means the function is transforming into what? T to s. Inverse Laplace transform means the function transforming into s to t. So this is the main difference between Laplace transform and the inverse Laplace transform. It's one of the most important and the primary formulas for Laplace transformation, right? Coming into the next one is one of the most important topic. Now we are going to see, find the inverse Laplace transform of by using partial fraction method. Look at this. How I'm going to find you that? I'm going to find, see, first question, inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform by using partial fraction method. By using partial fraction method. So this is also one of the most important topic, by using partial fraction method. Right. The question is, find the question is find L inverse of s divided by s plus 1, s plus 2, s plus 3 using partial fraction method. Using partial fraction method. Look at the question. Find L inverse of s divided by s plus 1 into s plus 2 into s plus 3 using partial fraction method. Already you know that how to split, how to use the partial fraction for the given function. Okay. Now let us take s divided by s plus 1 into s plus 2 into s plus 3. So this is the partial fraction method of type 1. It is a simple factor. So this can be split as what? A divided by s plus 1. Already you know that. So in the earlier classes already you studied what are the types of partial fraction. So this is the first type because of it is a simple factor. Okay, right. So this can be split as a divided by s plus 1, b divided by s plus 2 plus c divided by s plus 3. Okay. Now look at this here. What I am going to do is, you have to take it this, you have to multiply here. In this denominator term, you have to multiply in the numerator, and then finally we will get what? So this term get cancelled, finally we have only the numerator value equal to, if you are multiplying in a term, what? S plus 1 will get cancelled. So finally what is answer? So s plus 2, a into s plus 2 into s plus 3 plus b into, you have to leave it this one, and finally what is answer? S plus 1 into s plus 3 plus c into, you have to leave it this term, and finally what is answer? s plus 1 into s plus 2. So this is a working procedure to find what? Partial fraction method. Now we are going to find, our ultimate aim is to find what is the constant term, what is the value of constant term, to find the value of, capital A comma B comma C. How we are going to find the value of A comma B comma C, right? Look at this. How many factors are there? There are 3 factors are there. You have to equate to 0. So in place of s by, so s plus 1, so you have to substitute, put s is equal to what? Minus 1 in the all the terms. So if you are substituting here minus 1, s equal to minus 1. If you are substituting here minus 1, b term cancel, c term get cancelled. Finally, we will get what? A into minus 1 plus 2. So this is answer 1 and this will be 2. So therefore, minus 1 equal to 2a, and finally what is answer? A equal to minus 1 by 2. So this is answer for what? A. And what is second factor? Second factor is s plus 2. So you have to substitute, put s is equal to what? Minus 2. Put s is equal to minus 2. So instead of s by, if you are substituting s is equal to minus 2, a term get cancelled and c term get cancelled. Finally, we will get only for b. So you have to substitute minus 2 equal to b into, what is answer? Minus 2 plus 1, minus 1. So this is 1. Okay. So minus 2 equal to minus b. So b equal to 2. So this is second one. And coming into the third one, put s is equal to what? Put s is equal to minus 3. Put s is equal to minus 3. If you are substituting s is equal to minus 3, here term can cancel, b term cancel, and we will get only for c. So therefore, minus 3 equal to c into minus 3 plus 1. So this is minus 2 and then minus 3 plus 2. So this is minus 1. Look at here, substituting minus 3. Minus 3 means what? Minus 3 plus 1 minus 2. So minus 3 plus 2 minus 1. So therefore, minus 3 equal to 2c. Clear? So c equal to what? Minus 3 by 2. Now we are going to substitute in equation number 1. Okay. So I am going to substitute in equation number 1 all the values of a, b, c. Okay. If you are substituting here, what is the answer? S divided by s plus 1, s plus 2, s plus 3 equal to, what is answer? What is answer for a? A minus 1 by 2 divided by s plus 1. What is answer for b? Plus 2. 2 divided by s plus 2. Okay. And c, what is answer for c? So this is plus of minus 3 by 2 divided by s plus 3. Okay. Right. So this is the term. Now let us take inverse Laplace transform on both sides. So therefore, taking inverse, L inverse on both sides. Our ultimate aim is to find what? To find inverse Laplace transform. So therefore, so this can be written as L inverse of s divided by s plus 1, s plus 2 and s plus 3 equal to, what is answer? I am going to take it outside the constant term. So by applying the linearity property, so this is minus 1 by 2 into L inverse of 1 divided by s plus 1 and then plus 2 into L inverse of 1 divided by s plus 2 and next one is plus minus 3 by 2 into L inverse of 1 divided by s plus 3. Okay. So this is minus 1 by 2 into, what is answer? So already you know that formula. What is the formula for what? Laplace transform of that function L inverse of 1 divided by s plus a equal to e power minus at. Look at this. The formula is very important. Inverse Laplace transform. By applying inverse Laplace transform formula, L inverse of 1 divided by s plus a equal to e power minus at. So therefore, instead of a by, I am going to replace 1. 1 divided by s plus 1 equal to e power minus t. So L inverse of 1 divided by s plus 2 equal to e power minus 2t. And next one is L inverse of 1 divided by, instead of a by, I am going to replace what? 1, 2, 3. So therefore e power minus 3t. So therefore we are going to apply inverse Laplace transform. The first one is answer is what? E power minus t plus 2 into e power minus 2t minus 3 by 2 into e power minus 3t. So therefore L inverse of S divided by S plus 1 into S plus 2 into S plus 3 equal to what? What is answer? Minus 1 by 2 into e power minus t plus 2 into e power minus 2t minus 3 by 2 into e power minus 3 by 2. So this is the working procedure to find what? Inverse Laplace transform of partial fraction method. So this is type 1. You have to keep it in your mind. Okay, right. Yes, now let us see type number 2. So what is the procedure to find type 2 partial fraction method, right? So you try to understand that. One more time I am going to explain this. What is the procedure to find inverse Laplace transform of partial inverse Laplace transform, to find the inverse Laplace transform by applying partial fraction method. Look at the question. Find L inverse of S divided by S plus 1, S plus 2, S plus 3 using partial fraction method. The solution is what? You have to take it in this term. You have to split as a simple term. A divided by B divided by C divided by. So S is equal to, how we are going to write for this? You have to multiply numerator and denominator. So S is equal to A into, you have to leave it in this term, A into S plus 2 S plus 3 plus B into, you have to leave it in this term, remaining S plus 1 into S plus 3 and C into S plus 1 into S plus 2. And look at that. Our ultimate aim is to find what is the value of A, B, C. Okay, right. So there are three factors are there. You have to equate to 0. If it is S plus 1 equal 1 means you have to write it S is equal to minus 1. You have to substitute in this term. Finally, we will get A. So second term is S is equal to minus 2. You have to substitute in this term. We will get B. You have to substitute third one. And finally, we will get C. So therefore, A value, B value, C value, you have to substitute in that given one, equation number 1. So if you are substituting here all the values and taking inverse Laplace transform by applying this formula, finally we will get this answer. So this is the working procedure to find what? Laplace transform of inverse Laplace transform by applying partial fraction method, right? Coming into the second one, second type. I am going to tell you that second type. Look at that. The only difference is, what is the second type? Second problem is, look at the second problem. Same problem, I am going to write it second one, right? Look at this. Here, if it is coming into that square, find L inverse of S divided by S plus 1 into S plus 2 the whole square. How we are going to find inverse Laplace transform for this function, right? Look at this. What is the procedure? Already you know that. How we are going to find, how we are going to split the partial fraction as a simple factor. Okay, right. Now let us start the solution. So this is partial fraction of second type. So S divided by, look at this, S plus 1 into S plus 2 the whole square. How we are going to split for this? A divided by S plus 1 plus B divided by S plus 2 plus C divided by S plus 2 the whole square. This is the working procedure. Look at this. A divided by B divided by C divided by. A is what? A divided by S plus 1. This is a simple factor. If the square means we can split it as B divided by S plus 2 into S plus 2 the whole square. This is the procedure to split what? Second type, right? Now our ultimate aim is to find what? The constant value A, B, C. So to find A comma B comma C values. To find A comma B comma C values, right? Denominator, same as it is procedure, you have to multiply in the numerator each and every term, then you have to cancel, finally you will get the term. Look at this, I am going to multiply here. If you are multiplying this will be cancelled. So S is equal to A into, what is answer? If you are multiplying in terms of A, that S plus 1 is cancelled, so S plus 2 the whole square plus B into, if you are multiplying here, the only one term get cancelled. Finally, what is the answer? S plus 1 into S plus 2, because of S plus 2 into S plus 2. S plus 2, one term get cancelled. Finally, we will get what? S plus 1 into S plus 2 plus C into, this term fully cancelled. Finally, we will get what? S plus 1. Alright. Now, we are going to find constant term and constant term of what? A comma B comma C. Right. Here look at this, there are only two factors are there, s plus 1, s plus 2, but we need to find three constant. How we are going to find three constant, right? See, look at the coefficient. What is the highest coefficient here? The highest coefficient is s square. So therefore you have to equate what? Equating s square on both sides. Both sides. If you are equating s square on both sides, then what is the answer? There is no s square term. So 0 equal to, this is s square term, a plus b. Okay, a plus b. You have to keep it as it is. 0 equal to a plus b. Right. Now I am going to substitute in place of s by what? Second term. S is equal to minus 1. If I am going to substitute s is equal to minus 1, what is the answer? So minus 1. If I am going to substitute minus 1, b value, c value get cancelled. That becomes 0. So therefore, a into minus 1. So this will be what? Plus 1 the whole square. So minus 1 equal to a equal to minus 1. A equal to minus 1. If I am going to apply in place of 0 equal to a equal to minus 1 plus b. Okay, this minus is goes to this side. Then b equal to what? So b equal to 1. So a value equal to minus 1, b equal to 1, and finally to find c. Okay, now you have to substitute, put s is equal to what? S is equal to minus 2. If you are substituting s is equal to minus 2, then what will happen here, right? S is equal to minus 2, this becomes 0, this becomes 0, and finally we'll get c. If you are substituting s is equal to minus 2, so this is minus 2, this is c into minus 1. So therefore c equal to, what is answer? Only 2. So a value is minus 1, b value is 1, c value is 2. You have to substitute here. You have to substitute in this equation. Okay. So this is equation number 1. If you are substituting here, so what is answer? S divided by s plus 1, s plus 1 into s plus 2 the whole square equal to, what is the value of a? Minus 1 divided by s plus 1. What is the value of b? B plus 1 divided by s plus 2. What is the value of c? C equal to 2 divided by s plus 2 the whole square. S plus 2 the whole square. Same thing, taking L inverse on both sides. L inverse on both sides. If you are taking L inverse on both sides, so what will happen here? So L inverse of s divided by s plus 1 into s plus 2 the whole square equal to, so L inverse of, you have to take it outside, 1 divided by s plus 1 minus, then here plus L inverse of 1 divided by, what is answer? S plus 2 plus L inverse of, you have to take it outside 2, 1 divided by s plus 2 the whole square, right? What I am going to apply the formula, already you know that the formula, what is the formula? L of, already you know that, L of e power, L of L inverse of 1 divided by s plus a equal to e power minus at. So this is the formula, already I told you that, instead of a by I am going to replace 1. So therefore L inverse of 1 divided by s plus 1, then what is answer? E power minus t. So L inverse of 1 divided by s plus 2, what is answer? E power minus 2t. So I am going to apply here. So the answer is minus e power minus t plus e power minus 2t plus 2 into, look at here, how we are going to find the inverse Laplace transform for this function. We are going to apply the property for this. I am going to tell you in the next class how I am going to write for this. Directly I am going to tell you the answer for this by applying the property e power minus 2t into L inverse of 1 divided by s square. 1 divided by s square. So this is minus of e power minus t plus e power minus 2t plus 2 into e power minus 2t into, what is answer for this? 1 divided by s square. Already I told you that 1 by s square is what? T. So the answer is t. So finally L inverse of s divided by s plus 1 into s plus 2 the whole square equal to, the answer is e power minus t plus e power minus 2t plus 2 times of e power minus 2t into t. So this is the working procedure to find what? Partial fraction method. This is also one of the most important topic, right? So one more time I am going to tell you that, all of you listen carefully. So inverse Laplace transform by using partial fraction method, this is type 2. So find L inverse of s divided by s plus 1 s plus 2 the whole square by using partial fraction method. So this is second type. How I am going to say that this is a second type? Look at this, s divided by s plus 1 into s plus 2 the whole square. Look at this, this square means we can consider this will be a second type. So this can be rewrite as s divided by s plus 1 into s plus 2 the whole square is equal to, how to split for this? This is simple factor. So a divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 2 the whole square. This is the first step, equation number 1. And the second one is what? To find the constant term. Our ultimate aim is to find the constant term a comma b comma c, right? A comma b comma c. Here you have to substitute here the numerator. Then this term will get cancelled. Finally s is equal to, then you have to multiply here a into what? S plus 1 get cancelled, then s plus 2 the whole square plus b into this term. If you are multiplying this term, 2 get cancelled, s plus 2 whole square, s plus 2 get cancelled, remaining will get only one term. So therefore b into s plus 1 into s plus 2 plus c into, if you are multiplying inside, this term get cancelled, finally c into s plus 1. Here our ultimate is, already I told you that, to find the constant value a comma b comma c value, but here only two factors are there. How we are going to find third one? So therefore you have to compare the coefficient for this equation, which is the highest coefficient. So a term and b term have the highest coefficient, because of this is s square. If you are expanding this, we'll get what? X square. If you are multiplying this, s square. So therefore you have to equating s square on both sides. So LHS term, there is no s square term, so therefore this will be considered as 0. So this is a, this is b. So 0 equal to a plus b, then you have to keep it as it is. And coming into the next one, s plus 1. So you have to equate to 0 s plus 1. So this becomes s is equal to minus 1. You have to substitute here. Then finally what will happen? So we'll get a value. So a equal to, if you are substituting here, so minus 1 equal to, in place of s is equal to minus 1, minus 1 equal to a into 1 the whole square. So a is equal to minus 1. And finally you have to substitute s is equal to minus 2. If you are substituting s is equal to minus 2, what is the answer? This becomes 0, this becomes 0, and finally we will get what? C. So you have to substitute minus 2. Minus 2 is equal to C into what is the answer? If you are substituting here, minus 1. So minus minus get cancelled. C answer is 2. So a value, b value, c value you have to substitute in equation number 1. So therefore s divided by s plus 1, s plus 2 the whole square, a value, b value, c value. What is a value? Minus 1. B value is 1, c value equal to 2. You have to substitute here, and finally taking L inverse on both sides. So if you are taking L inverse on both sides, so you have to take it L inverse. By applying linearity property, you have to apply the L inverse here, L inverse of this term, L inverse of this term, L inverse of this term. Right, L inverse of, you have to take it outside minus. So L inverse of 1 divided by s plus 1 plus L inverse of 1 divided by s plus 2 plus 2 times of L inverse of 1 divided by s plus 2 the whole square. I already told you that. What is the formula? L inverse of 1 divided by s plus a equal to e power minus at. So this is one of the familiar formula for Laplace transform, primary formula. So instead of a by, I am going to replace 1, and instead of a by 2, what will be the result? E power minus t and e power minus 2t. Just you have to substitute here. So minus of e power minus t plus e power minus 2t, and coming into the next one. So this is by applying the property, I am going to tell you in the next class. So by applying the property, this plus 2 means we can write it as e power minus 2t. Then remaining will get L inverse of 1 divided by s square. Already I told you that 1 by s square can be written as t. So finally, so this is the solution. So L inverse of s divided by s plus 1, s plus 2 the whole square equal to minus of e power minus t plus e power minus 2t plus 2 into e power minus 2t into t. Right? Finish. So Jayamurthy sir.